I'm having so much fun making movies. I'm going to make a movie. I'm going to try and speed run building the Tic Tac Toe program. So as you can see, I've obviously already written this. This program works fine. Finds wins. But I'm going to delete all this code and start fresh and just sort of see how this goes. I actually wrote that a while ago, so it's not super fresh in my mind, but I'm just going to try and explain a little bit how I would tackle this problem. I'm going to go ahead and, before I forget, this has the register on click. Oh, it's defined up there. Okay. So I'm going to just hold on to this. This takes an x and y and a function that does something. Okay, so we'll just hang on to that. So right now I have a register on click that does nothing. This program actually works. I could even test this out. I could log. This may be a feature I haven't shown all of you, but this is called template strings. It's a kind of way to make strings where you include some values in the string by this dollar brace. And these are backticks rather than the regular single quotes or double quotes. And so in theory, if I click this, yep, you can see down in the REPL down here, it is in fact printing out wherever I click. So that's fine. Not all that useful, but shows that things are working. So let me think about how I want to do this. So the first thing we need, if we're going to have a tic-tac-toe game, is we're going to have a board that needs to get drawn on the screen. So I always want to put everything pretty much in function, so I'll just make a function called draw board. And it's going to draw some lines. And I want to think about where to put them. I know I'm going to draw 2 horizontal lines and 2 vertical lines. And I want to make this robust, so if the screen size changes, my board still works. So I'm going to aim to sort of figure out with math where I want to put it. So we know that we have the width and the height values, so I can find out, right now down in the REPL what they are, but I don't want to use those specific values. I just want to know that they exist. And so we can see this one happens to be the width is wider, but let's say the screen could change and that it could be taller than it is wide. So I want to get a constant, and I'll call it board size. And I want it to be, if I wanted to go all the way across the shorter dimension, I could use, math min of width and height. And I can actually run this. And in my REPL, I can evaluate board size and see it is 646, which is the height, which is the smaller one. So I could even go ahead right now and say, let's just practice, let's like draw a line. And draw line takes an x, which we'll do at width divided by 2, and the y can be 0, and the width divided by 2 again, and the y being, let's say, board size. And we need to give it a color, I think. So we're going to draw a gray line from down the middle of the screen. And nothing happened. Oh, because I defined the function. Several of you have had this problem too. And you can be like, I wrote this code, nothing happens. And I come over and I tell you, oh, you need to call the function, right? So this is the definition of the function. This is calling the function. So far, this function takes no arguments, so we don't have to pass anything in. But now if I run it, there we go, a nice gray line. Now let's say I actually wanted this to be a little, well, let's do one thing at a time. Okay, so there's a line that goes down the middle of the board. But we know that, suppose I want to center this, right? So it's going to span the whole height of the screen, but I want it to be centered horizontally. So I know that, if I recall from some of our exercises, that I can figure out, so if I say, let's see, I want the board X to be the width of the screen minus the board size. So that would position it like if this is the whole width and the size is kind of the height, then that would be the whole width is all the way to the right, I subtract the height of, the size of the board, and so that would get me back to here somewhere. Is that right? Actually, sorry, I want it to be 0. What do I want? All right, how am I doing this? Okay, width minus board size is how much extra space there is. If I divide that by 2, this is one of the problems I gave you. So that gets us sort of the padding, right? So we get the extra space divided by 2. That gets us to an X position. That should sort of be the edge, the left edge of the board. So now instead of width divided by 2, and I can do this feature I showed in the other movie, Command F2 to edit both of those. Oops. Oh, that doesn't work at all how I wanted. Let's undo all that. Try that again. Okay, Command F2. I want to just delete that and use board X. Now they're both changed. Okay, so now if I run it, okay, cool. And I could do another one at board X plus the board size, and that should be the, I could have done my multi-edit again, but so that looks like a square centered horizontally, and we'll note that if it had been, if the width had been the smaller one, this just would have drawn at the left and the right, because width minus board size would have been 0, and the board X would have been 0, and so it would have been 0. This would have been 0, and 0 plus the board size would have been the whole other thing. Okay, so that looks kind of right. Of course, the Tic Tac Toe board doesn't really have the edges drawn. It has lines at sort of 1/3 of the way in and 2/3 of the way in. So that actually suggests that I want to make a variable here. I can do it a couple different ways. We'll just do it kind of by hand. So let's just call it V1 for X1 equals board X, which is the position of the left edge, plus the board size divided by 3, so 1/3. And again, we're going to go ahead and change this to X1. And then let's just say const X2 equals, oops, I accidentally changed all of them, including the one where I was defining X1. So that should have been board X. Oh, I changed all of them. Okay, perils of multi-edit. Board X plus board size times 2/3. All right, so let me go undo my damage. This was board X. This was board X. And now I have X1 and X2. So if I draw, I'm going to copy this one, get rid of that. Let's see, does that work? Okay. That looks, not sure that came out quite right. That should still be right. Okay, it's a mystery. Not an. All right, I'm going to ignore that for a second and see how this looks when I draw the horizontal lines. Okay, so now we have to do a similar thing where the x's change, so it actually goes from board X, and we'll just say y1 board X plus board size, so that's the right edge, and the y's are going to be constant, so y1 and gray, and obviously I haven't defined y1, and I'm going to have a y2 as well, but now I can const y1 equals, and I'm going to go do the same thing as I did for board X. I'm going to make board Y, which will be the Y coordinate of the top left corner of the board. So in this case, I want to take the height minus the board size divided by 2 to get the extra, and that will be starting from 0, come down the extra amount. So that's actually going to, in this case, will actually be 0 because height minus board size will be 0. So board y plus board size divided by 3. It seems, well, I may discover my problem here. Plus board size times 2/3. All those variables, nothing's gray, should work. Okay, no, that does actually look right. I don't like, yeah, okay, so the logic was right. I don't really love that it's a butt right up to the edge, but this is now actually easy to fix because everything is defined in terms of this is defined in terms of the actual screen dimensions, and everything else is derived from the board size and those dimensions. So if I just make the board size a little smaller, make it like 3/4 of the smaller dimension. Oh, well, that didn't work at all. What did I do wrong here? It shifted. Height minus board size. What on earth? Okay, so interesting. I have a bug here. I can do some things to, while I'm here, I'll just change that and see, does it, like what? Okay, it did scale down. Oh. Yes, exactly so. So I forgot, when I wrote this, I forgot I had originally just drawn from the top, but I want to draw not from the top, but from the top of the board, which I had figured out as board Y. So now, if I run that, and I want to go from board Y plus the board size, which makes sense because that's what we're doing in the other dimension. And now that should work, but I can go back to my original plan to make this 3/4 of the size. Okay, so now I have a nice board. Maybe I even want to go ahead and, I think there was another, oh, dang it. Line width parameter. Yeah, there we go. A little thicker lines. Okay. So this is all fine. I was tempted at the beginning. I could do this with the loop. It's a little, like, is it really worth it to write a loop for just 2 things? Maybe I'll come back to that later if I get bored. Okay, so now we have a draw board, and we can click around. Nothing happens because I commented out the console log. So let's see. So the next thing I want to do, the way I would think about this is I want to abstract, like if I click somewhere in here, I want to know which of these squares it is. And I can think of this as being like a row and a column coordinates. So maybe this top square is 0, 0, and this is like row 0, column 0, row 0, column 1, row 0, column 2, all the way down to row 2, column 2, again using 0-based indices. And we'll see in a moment, those indices are going to be useful because we're going to use an array to represent the board. But for the first thing I want to do is I just want to finish like translating between graphics and those sort of abstract coordinates. So let me write a function which will be, I don't know, I'll just call it cell. That's pretty sure not what I did last time. But it's going to get an x and a y, which will be the graphical x and y coordinates. And its job is going to be to return a row and a column pair of coordinates. So I could do, actually, I'm going to do this even simpler. I'm going to make a function called row that takes an x and a y and tells me what row I'm in. Now, it turns out, actually, I only need to know the y value because the row can't change with the x. So all right, just go ahead and do that. So row is a function of y. So depending how up and down the thing we are, we're somewhere in here, or possibly even outside the board. So what I'll do, and let me just, actually, let me put this back and show like what happens. So if I click in this middle row, I get a y value of 597. Like there's other values. I can click a little higher up, 556. So if I took board y, which is 80.75, So if it's, and so we know that the board starts at board Y and it goes to board Y plus board size down here. And so basically if we take that distance, so we can actually say, that's basically, well, this size is literally board size. We could divide that into 3 parts. So each row is 161.5 pixels tall, but they start at board Y. So we could take this Y, the original, let's take 597. Let's subtract board Y. So we clicked here and it was at 597, but if we wanted sort of shift everything up so that the top is at 0, we would subtract this many pixels. So that gives us a value of 516. And then if we divide that by, if we divide that by this board size divided by 3, i.e. the height of a row, that's kind of our ruler. So if we had imagine a ruler that was as long as just this little bit of the line segment, how many of those lines can we draw before we get to the Y value that I actually clicked on, which was 597? 3. Is that right? That doesn't seem right. I feel like it should be smaller than that. Now I'm puzzled. 5. Wait, that's 595. Wait, why? Oh, duh. My original code over here was buggy. I was printing X for both values. All right, let's try that all again. So an actual value is Y370. Some of you have learned this in the REPL. If you hit the up arrow, it gives you old things you've typed in. So I didn't mean to be using 597. I meant to be using 370. And that gives me 1.79, which means if I come from here and I want to measure how many of this length I can go 1 and 80% of the way into the next one, which is about here where I clicked. So if we take the floor of that, we get exactly the coordinate of 1. Now let's click another up in this top row, a Y of 147. So we can put the same expression, put 147, and that gives us 0, which is correct because this is the 0th row. And as you might imagine, if we do the same thing with the Y down in the 3rd row, we will get 2. So 0, 1, 2. So this expression for any given Y value that we get will give us the right coordinate. Now you might ask, well, what happens if we click outside the board? And we can test that too. I can predict that it's going to give us like a negative value because we subtracted board Y. So we started with a negative value. And we get -1, which is kind of right. It's like it's before the 0th, and back here would give us 3. So what I think I will just do is I will say the row that we're in, I can use the shorthand form, is going to be this expression, the floor of the Y value minus board Y divided by board size divided by 3. Sorry, I have too few parentheses. I want that. Okay. And so now I can actually say, test this out and say, let's log the row of the Y value we just got. So now, if we click row 2, row 1, row 0, row -1, row 3. Okay, so that was easy-ish to develop. Obviously, I've done this particular kind of math many times before, so I kind of knew where I was headed. Hopefully, I explained how I thought of it. Obviously, figuring out the column is going to be very similar. It's going to depend on the X value, and it's going to start from the board X, but otherwise it is the same, and we can go ahead and add a printout of the x. And now we should see row 0, column 0, row column 1, down to row 2, column 2. Okay, so that's another bit of useful stuff. I'll maybe, just for grins, put that all in one line. Okay, so those are two useful functions to compute the row and the column. And that sort of gets us out of the graphical part of this program. So we have a board that's drawn wherever it's drawn, and the corresponding translation from graphical coordinates into sort of board coordinates. Okay, so now I'm ready to think about, well, I guess one thing I'm ready to think about is how to draw the markers into the board. So I'm going to make a function, draw a marker that's going to take a marker, and a row, and a column. And I'll just call it R and C here. So the names are completely local to this function, and we could use row and column again, even though it's used down here. I guess it's a matter of style. I'm going to just go with R and C for here. Okay, so now this environment has this draw text. The text we want to draw is the marker. I'm planning for that to be X or O. Now we need to translate from the row and the column back into X and Y. So just for now, let's just smack a marker in the middle of the screen to make sure things are working. We'll make it black. Oh, and we need to make it a size, which is another thing that's going to depend on the dimensions of the screen that we're drawing on. So I'm going to make that a variable, and I'm going to come back here, and I'm going to say, okay, well, how big should this font be? And this is in terms of, like, fonts are expressed kind of in pixels. So I'm just going to go with board size divided by 3. That won't work. Letters are different sizes if it's a proportional font or whatever. But that'll be roughly right. And so now I'm going to go ahead and say draw marker. I'll just hardwire it to do X. And I'm going to call row Y, column from X. And those are the 3 arguments it takes. You'll see these are grayed out because I'm not actually using them because I'm hardwired to smack it in the middle. So let's just see. Okay, so whatever I click is actually drawing a new one, but it's overdrawing the same place. That's right in the middle. And we can actually see, so the middle is right in the middle of the Tic Tac Toe board, but this X is positioned, like this is the point that we gave it is right at the bottom left corner of this letter. So that tells us some things. We need to shift this down and shift it to the left. So I'm going to maybe solve that problem first. So I'm going to just try and hardwire this to draw it correctly in that middle square and figure out how much I need to adjust it. And I can use my brain to figure this out. So it's in the middle. We need to shift it over. We could shift it all the way to, like, if we, we'll just see. So minus, actually, I'm going to go ahead and make a, because this keeps coming up. Oh, actually, font size is that value. So that's kind of appropriate to use here. So we're going to use like half of the font size. So that will subtract that. So that should shift it like, this is the font size, should shift it maybe there. Let's see. No, that shifted it all the way almost to the edge. So that's too much. So this is a little just sort of empirical. That looks kind of maybe. Let's call that good enough. Or so this is really the same as 0.2 times 0.25, but we want it maybe a little more to the left. So let's call it 0.3. That looks pretty centered, left to right, and the height is maybe similar. Now this part is not going to be the most robust. Except subtracting moves things up. So for the height, we want to move down. And that looks okay-ish. Let's call that good enough. So this is fine, except that it's always drawing in the center square because we just hardwired width -2 and height -2, which was the center of this square. So now we can look at this. The problem that remains is figuring out, given a row and a column, where is the center of that square? Like this point, this point, this point. So now we're trying to give a value for x. And I can just go ahead and even do this. Y height divided by 2 and replace these with x and y. So this hasn't actually changed anything, but except now this line is actually ready to go as soon as we define x and y appropriately. But just make sure that's all still working. Okay, great. So what is the x value of given a row and a column? So if row and column were 1, 1, it's literally that. But we should probably think of it in terms of, so if the x is determined by the column, so if the column was 0, we know where board x is here, and so we need to go half of a cell size, which I'm going to go ahead and define that. And this might look a little funny because cell size and font size are defined exactly the same, but they have a different purpose. And if I decided later that, you know what, I want the font to be a little smaller so that it's not so crowded or whatever, I could change that. But this math that I'm about to do with the cell size really depends on it being a third of the board size. I'm just defining this constant because I don't want to keep saying board size divided by 3 everywhere. In fact, I could go ahead and change some of these. All right, I'm going to just do a goofy thing here. No, I won't. Okay, so I could go ahead and change some of these now that I've defined cell size, and maybe that makes it even clearer what's going on. And then you could think of this as really 2 times the cell size, which kind of makes sense, right? The second line is at the x plus 2 cells. X plus 1, 2 cells. Or sorry, yeah. And same thing here, 2 times cell size. Okay, so that's maybe a thing I should have done before anyway. Okay, so I've got cell size, and so the center of actually very similar math. So board size plus whatever column we're in times the cell size. So when the column is 0, that doesn't add anything. When the column is 1, it adds enough to get us to this line. And when the column is 2, it adds us enough to get us to that line. And then we want to add half of the cell size. So this will actually work with the operator precedence, right? This will happen. This will happen. We could simplify that math a little bit if we wanted. So now, it doesn't work at all. What's going on? Oh, it looks like it's off by 1. Oh, I don't want board size. I want board X. Okay, so it's still putting it in the 3rd row, but it's putting it in the right column. So now we just need to do the same thing here. Board Y plus the row times the cell size plus the cell size divided by 2. So same logic, starting from the Y, meaning the top, the coordinate of the top. I'm going to go whatever column, many cells down, so 0, 1, or 2, and then from there, half of the cell again to get to the middle. So now this should always draw an X in the right square. And what's going to happen if we click off the board? Oh, it's going to draw a square over there. So that suggests there's a problem, which is we kind of want to just ignore those. So there's a couple different ways to do this. I'm going to push it. What's the best way to do this? I'm gonna make I think I did this in my other program. I just make a quick function valid, which is going to be really a row or a column. Let's call it C, standing for coordinate, and basically it's going to return if 0 is less than or equal to C and C less than 3. So basically C between 0 and 0, 1, 2, less than 3. And then here I'm going to say if, I'm also going to, tired of typing out this function all the time, row comes from Y, column comes from X, and then all of these I can just say R, C, R, C, and now I can say if valid row and valid column, then draw the marker. So this will evolve later, but this basic logic. Now if we click outside, you see it's still running, but when the things are out of bounds, they just ignore it, which seems fine to me. Okay, so the marker works. Oh, except and we're just always passing X, so it's always drawing an X. All right, so now the next thing is let's decide how to we want to draw an X or no. There's a couple different ways to do this. So one way would be to make actually a global variable that starts at X. I'll just show you a couple different ways. So if the marker is X, and then here, we'll just use that. So it's still the same, always drawing X. But what if every time we drew a marker, and we'll keep it out of draw marker because I want draw marker to just do its thing. But we'll say if marker equals X, set it to O, else marker equals X. So basically we're just swapping the marker back and forth. And what is going on? Type or assignment to constant variable, line 40. Right. The whole point of const is it means you can't change a thing. The point of the marker is that we're trying to change it. Okay, now the code is happy and it's drawing. We can see the O's are like positioned a little differently in this font, so it's not the most beautiful thing ever. We could put that in draw marker and be like, if the marker is O, like shift it a little bit to the left. I'll even do that. I'll say if marker is O, I'm going to say X. I want to subtract a little bit. So let's just do like, I don't know, an eighth. Oh, and some of you have learned this, some of you have not. Minus equals, this is a shorthand for writing X equals X minus. So basically whenever you're assigning a variable a value that is computed from the current value of the variable, some operator, and another value, you can write that in shorthand with the operator before an equal sign. So this means subtract from X, make the new value of X, the old value minus this. And so now, whoops, again, what am I doing here? Oh, I made const X const. So there's a couple ways to fix that. Quickest and dirtiest is to do that. Okay, that looks maybe a little too far, so I want to subtract less. All right, so if I really wanted to do this right, I'd have to be much smarter about these fonts and whatnot. I don't actually like changing the X to be not const, so I want to do it all in one expression. Do I? No, I'll leave that alone for now. Okay, that's fine. Okay, so now we've got our marker switching back and forth. Another way to do this, which I think some of you came up with, and which I kind of like, because I feel like it'll be useful to know this other thing, which is what move are we on. That also determines what the marker is. If it's an even move, it's X. If it's an odd move, it's O. So here, I can say M, which is going to be our temporary value for marker, is if move, our old friend, mod 2 equals 0, meaning it's even. And then I'm going to use the ternary operator, which some of you may recall from the Pig Latin exercise. This is kind of like an if statement, except for an expression. So if move is even, we're going to set this value M to X. Otherwise, we're going to set it to O. So this is an expression that evaluates to one of these two values depending on this Boolean. So when this Boolean is true, it's this value. This Boolean is false, it's this value. And then instead of just marker, we pass M, because marker doesn't actually exist anymore. Actually, so we could call this marker, to be clear. And now this should, and this will only change if move changes. So we're going to increment the move. So move will always be the current move, and we can throw that in our debugging output if we want, just to see it. So now, move 0 we draw on X, move 1 we draw on O, X, O, X, O. Now, oops, there we go. So it actually let me draw multiple marks, so that's actually a problem that I should fix. Okay, but so far so good. So now we've got our click handlers getting a little more complicated. I've added some functions. Let's format. All right, and I guess I'll just keep going from here. Let's see, we've got this move. All right, so I think at this point we've got the graphical part going, but now we're running into the problem that, like, we need to know things. We need to know where we have drawn a mark, and that is a job for arrays. So, and this is a very common way that programs are structured, where you have sort of a graphical or some kind of UI, and then you need a data structure that can represent in a more abstract way what's going on. And so what I'm going to do, this is actually, I think, an example straight out of the slides. I'm going to make a 2D array. You can think of it, or you can think of it as an array of arrays. So board is an array that goes from this bracket down to this last bracket. It has 3 elements in it. Each of them is an array that has 3 elements, and it starts out with those elements being the empty string. And so the purpose of this array, and this is actually the real reason, or one of the reasons that I started out by immediately translating X and Y into row and column 0 to 0, 1, 2 kind of coordinates, because those are going to be the indices into my board. So I'm going to go ahead now and break out this bit of code into a function which I'm going to call make move. That is going to take as arguments the row and the column we want to move at. It can go ahead. Actually, I'm gonna leave that here, but just because, so you may be wondering, like, how do I decide what to put where? And the main thing is I want functions to, like, have a single purpose. Let me fix the formatting here. Okay, so make move says it makes a move, so I don't want it to, like, sometimes not make a move if the row and column is given are invalid. So instead, I will assume that I'm going to arrange to only call it when I actually mean to make a move, and then it will do its thing, which is to make a move. But the reason I broke that out into a separate function is because it's about to get just a little bit more complex. Namely, in addition to drawing the marker, I want to set an element of this 2D array, namely the element that's at the given row. So if we're in row 0, we want to get to this array. And if we're in row 2, we want to get to this array. And then whatever column of that row, so if we're in row 2, column 1, that would be this element. And I want to assign it the marker. So that should work. It won't have any discernible effect and will not prevent me from playing in the same squares. But we're now, in fact, we can print out board and see that it has recorded the most recent move in each square into that board array, which is all here printed out all in one line. But that gives us a chance to say, have we already played in a particular spot? And that suggests that I can actually break this condition out. And I'm going to use that feature rename symbol. I'm going to rename valid to valid coordinate because I want, well, just to make it a little more explicit. And then I'm going to say valid move is going to take a row and a column and is going to return, for move to be valid, it has to be, valid coordinate row and valid coordinate column, and board at that row and that column has to equal the empty string. Because if it's anything other than the empty string, that means we've already put a marker in that square and it is not a valid move. So now, instead of just checking the coordinates are valid, we check, is it a valid move? And if it is a valid move, then we make it. So now, suddenly, it's clicking, but it's not doing anything any more than if I clicked off the board. But as long as I click in empty squares, it goes. Now you may see the problem here, actually 1 with X, and the board we didn't notice because I haven't written any code to do that. But if we now print out, can we see? Where am I should fix that REPL so it prints stuff before the cursor. All right, so we can see the board is all completely filled in, meaning the board data structure as befits or it matches up with what's on the screen. So XOO in the first row, XXX in the second row, OOX in the third row. Okay, so I'm going to go ahead and take this printout. This doesn't seem to be getting me a ton. And that, so now we're left with, okay, so we've got a board that we can click in, we can draw the marks, but we can't detect winning or losing. So now it's a little, now we think, so we've got this data structure. How can we tell, well, basically we want to write a function that will pass in the board, or I guess it could reference the board because this board is global and available everywhere, but I guess we should be consistent. So here we didn't pass the board array in, we just used the fact that it's, since it's defined at the top level of the file, it's globally available. So maybe we'll just carry on with that. Okay, so what we want to do is we want to write a function that checks if there is a winner. On the board. And there's a couple ways we could do this. So given the rules of Tic Tac Toe, we could just check the like start from the last move, like we just made a move. If there's a winner, it's either in the row that we moved in or the column, or if we're on a diagonal, in the diagonal that we're on. Since Tic Tac Toe is so simple, it might be easier just to write a function that just looks at the board, doesn't pay any attention to where you moved, and so it doesn't actually need any arguments. But this will return, we could either write it to return true or false, like true if there is a winner, and then we know that the player that just moved just won. Let's just do it that way. I don't know. There's a couple different ways to do it. So what do we have to do? We have to check if there's a winner in a row, which is actually very easy if you think about how our board is organized. Each of these arrays is one row, so we could check if all the values in that one of these subarrays is all X or all O, then that's a winner. Columns are a little harder because they're not already in a nice array. And then the diagonals are even worse because they're like one value from each of the 3 rows. But that doesn't seem like an insurmountable problem. And there's a couple different ways to do this. I will demonstrate one, which is kind of nice. I will do it a little more explicitly than I might if I pulled out all the stops of using fancy JavaScript techniques you haven't learned yet. But I will make a variable called lines whose value is going to be an array. And this is going to be an interesting array. It's going to have 8 elements in it, each of which is itself going to be an array. And the values in that array are going, no, let's see, is this going to work? Sorry, this technique works less well with this representation. How shall we do this? All right, we can do it this way. So this is actually a little bit complicated, so like get a cup of coffee and pay attention or whatever. But the elements of these arrays are themselves going to be arrays which are just going to be pairs of numbers, which are the coordinates, like the row and the column of a square on the board. So this 0, 0 represents the row and column 0, 0. And each of these, this array is going to be the coordinates of one of the lines on the board. So we'll start with the rows. So this is the first row. The coordinates, the rows are all 0 and the columns are 0, 1, and 2. So if we copy that, I could build this up with some code actually pretty easily, but maybe it will be easier to see what's going on if I actually make the data explicit. So you can see these 3 elements are, I can even comment it, the rows, so row 0, row 1, row 2, where the second value is the columns. And then I'm going to do a similar thing for the columns. In this case, it's the row value is going to change, and the columns are going to stay the same. So that's the 0th column. There's going to be 3 of those. And there's only 2 diagonals. Just copy that. Okay, and the diagonals, the first diagonal goes from 0 to 1, 1 to 2, 2. So 0, 0, 1, 1, 2, 2. The other goes from row 2, column 0, also through 1, 1, and up to row 0, column 2. Okay, so that was a little bit tedious, but we'll have some kind of reasonable payoff in a second. Okay, so basically, this is a technique called data-driven programming. We're now going to write some code that's going to use this data to do something that we might otherwise have had to write, like a bunch of if-else constructs. So basically, the question now is, is any one of the elements of this outer array lines that gives us a set of coordinates, if all of the values in the board at those coordinates are the same and not blank, not the empty string, then that line has a winner. So this is kind of a classic do we find a winner situation. So we're going to do our standard loop over an array. And I'm going to defer. This is another technique for keeping your code from swamping you in complexity. I know kind of what code I have to write here, and it's going to be just like a little bit complicated. It's probably going to involve another loop. So I'm just going to push that off by imagining that I had a function isWinningLine that takes one of these lines. And I'm just going to pass it, extract the line with the index operator from lines. And what do I want to do? If there is a winning line, that means we found a winner. So we return true. Otherwise, after we've looped through all of the lines, if we have not already returned true, that means we didn't find any winners and we return false. And so it's easy to see that this function is correct, except I haven't implemented the hard part yet. But now I can focus on writing that function. isWinningLine is going to take a line, which is going to be one of these values. And so that means, what do I want to do? One way to look at this is the mark. Let's do, okay, so first cell equals line 0. So this is going to be something like, right, line looks like one of these values. So the first line that we're going to get passed in the isWinner from the isWinner function is going to be something like this. The 0th element of that is this. So it's actually first cell is going to be something like this, a row and a column. And I guess I will show you a trick that I have shown some of you. So we could write this as row equals the first cell 0, and the column is the first cell 1. And that's perfectly fine. So this R would be this first value, and this C would be the second value. That is such a common thing to want to do with arrays, and as we'll learn later, also with objects, that JavaScript has a special bit of syntactic sugar for that, which is you can, after a declaration like const or let, put the variable names you want to declare also inside brackets in kind of the same structure. And it will map the values from this value. Line 0 is going to be an array with 2 elements, so it'll map the first element to R and the second element to C, and we don't have to mess around with that other variable. So this is an easy way to extract the row and the column of the first element of the line. And then we can say marker equals board, row, column. Now what we want to know is, are the other 2 elements the same marker? So if marker if the first marker is empty, then clearly there's not a winner. The line isn't even all the way filled in. So if it's not empty, and then we can go ahead and say if it is empty, we're just going to go ahead and return false. But in the case where it's not empty, then we want to know, are the next 2 elements of the line the same marker? So one way to look at this is say return This is getting a little bit hairy. If the marker equals, all right. Again, nothing super complicated what I need to do here, but I'm going to have to extract like the marker from the board for a given element of the line. Basically this code again. So rather than write that code a bunch of times, I can write a helper function, marker at, and so now coordinates is going to be a value like this. So I can paste that code I just copied. And so instead of line 0, now it's going to be coordinates. And I will just return the value of the board at that row. So this marker at will just translate one of these to the marker at that pair without us having to sort of take apart everything. So now we can just say marker equals marker at the first cell of the line. And so we've abstracted away the gorp of like taking apart the coordinate and using it as indices into the board. And so now we can say return marker. We've already determined it's not the empty string. So if the marker equals the marker at line 1 and the marker equals the marker at line 2, then if this is true, then the whole thing is true. If either of these is false, then even though this wasn't empty, we found a mismatch, and so we return false. And if we get out of there, right, or rather if we skip past this, actually we can make this one a little more explicit, where it's either, oops, either it's not empty and we return if it matches, otherwise it's false. So that now feels like, I guess we could have written this. Yeah, I don't know. There's different ways to write it. We could have written it with a loop. We could have written it with some of the fancy array functions that some of you have learned. But this is straightforward enough. And the other nice thing about having small functions like this is you could write this function any of a number of ways. But as long as it meets the contract of like you give it a line and it returns true or false, doesn't really matter. So if you don't like this style, you can write it in a different style. But the rest of the code doesn't really care. So I haven't run this in a while. Let's just run it to make sure that it's okay loaded. So at least it's not syntactically wrong. We're not using any of these new functions, so nothing is happening here. But we can, I guess, quickly test that because in theory, isWinner will check if there's a winner, and we can just log that there's a winner. And so and we'll log that there's no winner, so we know that our logging is happening. Okay, so now every time we move, no winner yet. If we click outside, nothing happens because we're still in our valid move check. No winner yet, no winner yet, no winner yet. Winner! Okay, so we actually detected the winner. Doesn't stop us from continuing to play, and it continues to know that there is a winner. In fact, there are now 2 winners. So that's another bit of logic that if there is a winner, we need to stop. So what did we do here? We added all of this data. That was perhaps the most tedious part. So to test that, let's get a winner some other way, like the diagonal also found the winner. Can try one of the columns. Found the winner. So as long as I entered this data correctly, that should work perfectly well for all 8 of the possible lines that you can win on. So all over 100 lines of code, 15 of which are just this data. And what's the next thing a tic-tac-toe game should do? So it should stop us from moving if once someone has won, perhaps. It should draw the line is another fun bit, and then maybe after the game is over, you can start a new game. So let's start with it seems easier to me to disable moves after there's a winner. And since everything happens in this on-click handler, basically that just means we need to know if the game is over. I mean, one way to do it, actually pretty easy, is if there's no winner, not a winner, and it's a valid move, then make the move. So that should actually just do it. So this is another, shows sort of the advantage of breaking out these small functions, is that they have useful, they often tend to be useful in slightly different contexts. So now, after there's a winner, clicking doesn't do anything. So I really just had to add like 8 or 9 characters and use a function that I had already written, and I implemented the next feature. So that was pretty easy. Now it's a little redundant that I'm checking right after the move. I'm checking to see if there's a winner and then logging it. I guess I could. So tic-tac-toe is really simple, and this is a small game, and it doesn't really cost anything to check it twice. But if I really cared about efficiency or just whatever, I could say, well, if that's probably fine. I would just keep printing winner as long as you click. So I'll just leave it like that. Let's see. There was a couple little. I'm basically stalling because I don't want to implement the line drawing because that's like a drag. But I mean, I don't really mind. But as I was going, there was a couple of things that stuck in the back of my mind. One was this board X and board Y. And there was a point when I was describing like, well, board Y is really the top of the board, and I was describing the math. And it's so easy to rename things in this editor, so I should really do that. Like board Y, you kind of know what it means, like, but it is really it's like board top. Oops. And that changes it everywhere that I referred to it. And board X is board left. And that's just a little clearer. It's a little, a little more obvious. Like board X and board Y, if you remember that it's really the coordinates of the top left corner of the board, that's fine. But you have to remember that. Whereas at board left, it's like probably a little more obvious that like, okay, that's probably the left side of the board, the coordinates of the left side of the board. I mean, we could say board left X or something, but left and right is always X, so that seems a little gratuitous. So that's one simple cleanup that stuck in my mind. I just didn't get around to making before. What was the other one I was just thinking? I guess since I taught you this technique of this, that is called destructuring, where you're basically taking apart the structure of the values of coordinates as a list, and we take it apart into 2 separate variables. That also suggests that we could slightly consolidate coordinates as a function from X and Y to the row and the column. And basically we just want to return, we could use the row and column function, but the plan is to just get rid of them entirely. And so we want to return an array of the row and the column value And so now the idea is, now I got to find, where did I call row and column? Oh, that was down here. So now I can just say in one line, the coordinates of the x and the y. I don't know that makes things a ton easier. Again, the fact this variable name as the argument, the name of the argument to this function, is the same as the variable that's holding this function. Doesn't really matter. Right? The name we used here is the same as the name we used here. It is fine because we're not trying to refer to this function inside the body of marker at, but it's maybe a little confusing, so I might abbreviate this. Well, not really necessary here, there's just two, but I'm going to abbreviate that to coord. And so basically what we've done is we've sort of introduced or regularized on this. Well, we express the coordinates on the board in these arrays of row and column. All right. Board size divided by 3 here is really the same as the cell size, which this is a little more expressive. So the row is the distance between the top and where we clicked, and the cell size divided by the cell size. The cell size is kind of our ruler, and likewise for the column. Okay, so that should all still work just as well. Finds a winner, stops us from playing some more. Okay, so now it's time to actually deal with drawing this line, which is nice. So one thing, let's see, did we, somewhere in here we were figuring out where the middle, this draw marker. Okay, so, great. So this is an opportunity. So when we were drawing the markers, you may recall, we started by figuring out where was the center. And that was actually just luck that, because I smacked the first letter in the middle of the screen, which happens to be the middle of the square, and then I sort of worked it out from there. So some of this code here, basically this board left plus c times the cell size, was designed to find, actually this whole thing is designed to find the center of a cell of the board from its row and column. So let me copy that out. And cell center as a function of the row and the column. All right. So that function we're not using yet, but we can test it out over here. So what's the center of 1, 1? Is that width divided by 2? Yep. And height divided by 2? Yep. So that figured out the center there the same way, comes out to the same place. Okay, so that's a good sign that it probably works right. So now that we've broken that out, we can do the same trick over here. So we can do the destructuring with let. It's making y also mutable, but that's fine. Makes this a little bit simpler. And I think, I guess that's fine. Okay, so yeah, we still have this little fudge of shift the x value a little bit if it's if the marker equals 0. Maybe another way to do that, I might do this. Just make a variable nudge, which if the marker equals 0, the letter is the cell size minus 9, otherwise is 0. So we nudge it if it's an O, we don't nudge it if it's not. So then we're going to subtract that. So basically how much we want to shift the X value is the font size plus the nudge. So that should work the same. And now we don't have to modify X, which is nice. So we can make it const. And that should work. Right, the O gets nudged over a little bit. Looks like the X should actually get nudged too. But all right, I'm not going to worry about that. Because it doesn't look like it should get nudged quite the same amount. Maybe. I don't know. So that's a little nice. Okay, but the point of that, because the lines, we could imagine, also want to go from like, we could start by drawing them from the center to the center. Now that suggests, so if we find that there's a winner, when we found it, we knew what line it was. It was a particular line. And that line had the coordinates. And we could use those coordinates to figure out where the center of the cells are in the graphical context and then draw the line there. So that suggests that it might be nice, instead of just returning true or false, to return the line that contains the coordinates of the winner. So this is a little bit... actually, this I have to introduce one thing that we haven't really talked about, but objects and arrays, they're sort of an even more empty than just like an empty array, like a non-value, which is called null. So basically the idea here, instead of returning true or false, we return either an actual array that came from our lines array or null, and that's a distinguishable value. So now we can, I will do it kind of the explicit way. So if is winner equals null, so then that means that there was no winner, so the winner is null and is valid move, then we do all this stuff, same as before. So this should still work. And it still stops us. Okay, so that was fine. That didn't change anything in particular. But now we have this. And I guess, so I revealed that this actually also just works because null counts as a kind of false value, and an array that's not null counts as a true value. So I didn't really have to do the same thing here. But if I wanted to be explicit, I could say is winner not equal to null. But I'm actually going to do something else, which is I'm going to say winner is not such a great name anymore. I'll fix that in a second. But if the winner is not equal to null, that means we found one. And so not only can we, I'm not sure that's going to log in a useful way, but we'll at least see that it happened. Oh, it did show it, kind of. You see it doesn't show the brackets, but 0, 0, 1, 0, and 2, 0 down that column. So that means we have the array, and we could figure out, so let const So what I'm doing here is I'm extracting the row and the column from the first cell and the last cell, which I could also write as winner length minus 1, as I have taught you to do. In this case, we know it's 3, so we could cheat. I'll do it this way. So now I have 2 row and column values, and I can cell center row 1 column 1 const x2, y2, cell center, row 2, column 2. And now we have pretty much everything we need to draw a line from x1, y1 to x2, y2 in the color, let's say red, in the thickness 5. And does that just work? Let's see. It does. 5 is kind of too thin. 15. That looks pretty good. Also reveals that the X is not quite centered right, because it should be like, feels like the line should go right through the center of the X's. Let's try letting O win. Those look okay-ish. So that suggests actually this nudge, where did we put nudge? Shouldn't be 0 for X, but should be, I don't know. I mean, should it be the same? In which case we won't really need a variable for it, but we can try it. X, O, X, O, X. Nope, that's too much. So the X does in fact need a smaller nudge than the O. That looks pretty good. Maybe just a shade too much. So we want to nudge it less. Look at that. Okay, so that is pretty good. If you have a really good memory, you might recall that on my original one that I demonstrated before I deleted all the old code, it actually drew the lines a little bit longer, which I think is particularly noticeable on the diagonals. It's like, I feel like it's just, the line should go like from even beyond the perimeter of the board dramatically across. So figuring that out is just more math. Maybe I'll wrap it up here. Oh, maybe I'll record it and maybe I'll edit this out if it seems like it's too long, or cut it into a separate video or something. So let's see if I can do that last little bit. So we still have the, like, it's not letting us play anymore. If there is a winner. Now that we have a more dramatic reveal of the winner, we can maybe take out this console logging, just because that was just there to let us know things were working. Oh, I wanted to change. So is winner is like a bad name now, because it's implies that it's a Boolean value, and it's obviously excuse me, not Boolean anymore. So I just want to rename it, and it doesn't have to be complicated. Maybe it's find winner. So that implies that if it finds the winner, it returns it, and it returns null if it doesn't find one. And if we really wanted, it's not worth it. But just to show you, if there was a lot of places that we were checking, like find winner equals null, it's a little bit annoying. We might actually want our isWinner function back that returns a Boolean, and we can implement it easily enough. Like, there is a winner if find winner returns something other than null. And so, like, for instance, we could put this code back to, if there's not a winner and is a valid move, go ahead and make the move, and then find the winner if it's not. And here we actually want the winner, so we use find winner, and if it's not null, then we do all this stuff. So a little bit matter of taste, whether you like that. Let's make sure I got that right. Yep, okay, so that works. And so what did I say the last thing was? Oh, so now this, if we want to make this draw line a little fancier, or the line drawing, extend from beyond the center, then that suggests that this code, maybe from here, or really from inside, like the body of this, which is really just figuring out So I'm making this new function that takes a winner and does exactly what we did before. And this should just work. I just literally just replaced this code that was all in line here with a call to a function passing the same value. Since I named the variable here the same as the variable here, they don't have to match. This could be, anything. I would still work just as well as long as it wasn't some other name used in the function, but I'm gonna sometimes it's useful to have you can sort of see how things line up by the variable names. So this winner in here, we get the coordinates, translate to the center, and then we draw the line. So that should still work. And all we really wanted to do is we just want to extend this line a little beyond the bounds of the square. Couple ways to think about that. Not that great at geometry, but fundamentally this is a line that has some slope, and we just need to I guess what is the way to think about this? It is going down some amount and over some amount, and we want to go up and over, in this case, up and over in the same proportion. So we know let's see, const down equals, let's see, y1 minus y2, const over equals x1 minus x2, and there's obviously signs here. I don't think we want to do the absolute value because we actually, the signs, it might be a line going up and to the right, I think, because that's how we did those. It might be a horizontal line. So what do we want to do? We want the starting x, let's take it one step at a time. The starting x, instead of being x1, which is the center, we want the starting x to be over, I guess we could say we want it to, basically if we wanted it to go outside of this box, so this is halfway, so we want to go half of the cell size, maybe a little more than half, to this much, and then we want the y, I guess it's the same amount since these are center to center, in this case because it's diagonal. So we want, but if it was a horizontal line, then the down would be 0 because they'd be on the same horizontal, and the over would be, so really I guess all we care about is it 0 or 1. If it's a flat horizontal line, the y doesn't change at all, only the x changes. If it's a vertical line, the x doesn't change at all, but the y changes, and if it's a diagonal line, they both change. So let's do this. Since I'm not sure, I'm gonna do this in small steps. So I'm gonna say if the, so really what maybe I don't even care about how much down or how much over, but if, so if y1 equals y2, that means it's a horizontal line. Horizontal. Okay, if it's a horizontal line, then that means we want I'm going to do this, let adjusted x. All right, this is going to be really gross code for a sec while I figure it out. And then I'll probably be able to clean it up. So I don't think I need that. All right, so if it's on a horizontal, then we just want to Then we know it's a row. We know that the first X is like in one of these columns, so we just want to subtract adjusted x1 equals x1 minus cell size. Could think of it as divided by 2, like half the cell size, but maybe we want a little more than that, so let's do like 0.6. All right, so this should handle if we win in a row. Yeah, the line started further off. And we can do the same thing. If it's a horizontal, it's going to be cell size. Oops. Oh, I didn't use adjusted x2. Try that one more time. X, O, X, O, X. Okay, nice fat line, extending a little bit beyond the board as one would actually draw it. So that's the horizontal. Probably this code is going to be basically the same, except if x1 and x2 are the same, that means we're on a vertical, which means adjusted y1 and adjusted y2 are going to be the old ones. We're relying a little bit on the fact that these were set up so that like the rows all go from left to right and the columns go from top to bottom, I think, right? Yeah, row 0 to row 2. So we kind of know whether we need to add or subtract here. So the y1 is like this, and we want to subtract to get a smaller value. And at the end, we want to add to get a bigger value. So that could look very similar. But, oh no, what happened? It didn't draw it. Something terrible happened. It didn't find the winner. Did I break something? You'll notice, while I'm puzzling that out, you'll notice that these variables are still gray, even though they are assigned values here, and that's because the assigned values have never been used. So it can tell, the editor is smart enough to know, you've declared these, you even assigned them new values, but you haven't done anything with them. So if I change that, I don't think that was actually the problem though. Like y1 and y2 were still perfectly good values. So what happened? All right. Now I'm a little mystified. What did I... draw? So either we're not calling draw 3 in a row or it's not working anymore. Which is more likely? I don't know, but it's easy enough to find out. We can say drawing line. Okay, it thinks it's drawing the line, but it's not drawing the line that we can see, which suggests that I've set these y values to something nonsensical or something easy enough to find out what that might be by adjust x1, adjust x2, sorry, I want that x1, y1, adjust x2, adjust y2. Try one more time. Oh, undefined. Cool. What happened? Oh, yes, indeed. Yes, so this is always very edifying when you get an undefined. That means, right, I declared all these, and then I set them in one case, but if I didn't go into this branch, they never got set and they got their default values. So really probably I want these to start out at the unadjusted. Good, and that works. I bet the row works still. Okay, but what we don't have is a good diagonal. So when the diagonal case is when neither the x nor the y are the same, right? Or the chain, like the x1, this is x1 to x2, y1 to y2. Okay, so probably, really there's three cases that are mutually exclusive. So we can combine them this way, and basically if we end up here, that means we're in the diagonal. And so we want to, how do things get adjusted? Adjust x1. It may just be the same, right? Sorry, I triggered Siri. So this isn't going to be quite right, but it'll probably handle the first diagonal at least. It may just be all of these. So I'm not really thinking too hard about this because either it'll look right or it won't, and if it's not right, I will see that it is not right and think a little harder. So that looks pretty right. And the moment of truth, totally wrong. Okay, what happened on the other diagonal? Things shifted all in the wrong way. So when it was this diagonal, things were fine. This one, we should have been at x, should have been here. And so in this case, we wanted to, looks like we shifted the x the right amount, but the y went up when it should have gone, right, so the y got subtracted, as indeed this says, and this one, also the x looks right, but the y. So basically, right, when we're drawing this way, the slope is going the other direction, and so the y needs to flip sign. So that's kind of tedious, but the two y's, so basically, again, I'm going to just make really gross code here for a second. So if y1 is less than y2, that means the y value of the first square is less than the y value of the second square, then we're in the case that we handle properly at the moment. And else, basically we want to do all of this, but backwards. So we're going to just flip that sign, reformat, and I'm hopeful that that works. Let's check that the other diagonal still works. Certainly should. Okay, so that is fine. This is starting, like, this is getting pretty hairy. This is like some of the code in the other videos that I was like, this is too hairy. There's too much duplication here. You know, the two branches of this if are the same, except for just the sign of these two things has changed. So, but now that I've got the basic concept, I can look at how can I clean this code up. And I think, well, this last bit is easy enough. So let's say if y1 is less than y2, it'll be 1. Otherwise, it'll be -1, right? Because we want to flip the sign. And so basically, we want to do the same thing, but so this was the case where it was y1 minus y2. So we can slope times that. So when it's 1, this code does exactly the same thing as it did before. And when it's in the else case, it'll be -1, and so it should do the same thing we wanted. So check, looks good, also good. Okay, so we did a little math, got rid of some logic. That seems nice. Also note that the two x adjustments are the same in the diagonal case as the horizontal case. So that's feels like I should be able to express, what is it? So if y1 equals y2, it's horizontal, or is that right? So if y1 is y2, that's horizontal. That's x1 not equal to x2. So we only get to this x1 not equal to x2 if y1 is not equal, right? Because if or, as soon as the first thing is true, the or will be true. So the only way that this matters is if y1 is not equal to y2. If y1 is not equal to y2, then and x1 is not equal to x2, that means we're on a diagonal. So this will be true when we're on a horizontal. It will also be true when we're on a diagonal, which means that these x adjustments can go in the same place. And I feel like so that means this. All right, well, I don't know if that's better, because now we have this sort of separate thing for the diagonals. But maybe these are isolated. So if it's a horizontal or a diagonal, then we have to adjust the x. If it's a vertical or, by this kind of same logic, a diagonal, then we have the same adjustments, except for this one has the slope. The slope is 1 when y1 is less than y2. It should also be the slope here, which is really the place, like the old vertical case was x1 and x2, which means y1 is actually equal to y2. So it feels like we can take the slope and say if it's less than or equal, then we want the slope to be 1, in which case these two expressions and these two expressions are the same. But obviously we want the one with the slope to handle the case where it's not. Okay. So this is still not like my favorite code in the world. The vertical is handled. The horizontal is handled. That diagonal is handled. This diagonal is handled. So that feels rightish. We don't need our debugging statement anymore. And it's not the worst thing in the world. So, all right, we extract the coordinates, we translate them to x, y, and then we get these potentially adjusted values which then only get adjusted and when needed. We can also simplify this a little bit. Since these start out with those values, that also kind of expresses it like, oh, we're adjusting. And then same thing over here, except that we want to, that's minus equal, that's plus equal. The slope, the sign still flips it, so like if you minus equal, meaning subtract this value, but then the value is in fact negative, it's the same as adding, so that should work the same. Whoa, it does not work the same. What did I do? Okay, surprises are always interesting because, all right, well, at least I broke them both. Oh, wait. Oh, I just broke this. This was plus, I think. Okay. Right. Also, anytime something breaks, it's like what you just changed. So you just think about what did you just change? Or in some cases, you go back to version control and see how it was before. Okay, so that's starting to be a little better. I have this bit duplicated a lot. So I'm gonna do this trick from the other movie. Copy that. Do the multi-edit. Change that to adjustment. Oh, dang it. Sorry. Click to get out of the multi-edit and then say const adjustment equals that value. So on that, if I wanted to change this and make it even more dramatic, I could just come over here and suddenly it's bigger and I don't have to change a bunch of lines of code, though that would be easy with the multi-edit. It's not the worst thing in the world. I haven't made a big point of this in class, but basically every time there's a pair of braces, it creates what's called a scope, which means the name is only meaningful with inside that scope or with inside these braces. So in general, it's a good idea to put variables that are only used in a certain place inside that same scope. So it doesn't really matter here, but it just means we don't have to worry about it. If I could declare slope, as soon as I got y1 and y2 up here, but then you'd have to be thinking for the whole function, hey, what is that slope variable for? Whereas here it's very obvious. It's only used in these 3 lines. So we'll talk more about that later in the year. I think, so that basically covers it. I've got this cell size. I could take adjustment. I might do this, move it up to the top, because this is kind of a, it's not really, I guess I often say like you want to avoid global variables, but this is kind of a magic number. Like why is it 0.7? No reason except that it kind of eyeballed it and looks good. And if I wanted to change it, I could just change it up here. I don't have to go digging down into some code. I might rename it now since it is global. It's not clear what adjustment it is, but like I call it line adjustment, line end adjustment, maybe. And now it should still be fine. Great. Okay, so that's pretty much it. I think that was like all of the things I said you could do. Detect when a player wins and draw. Yeah, so I did the whole assignment. Took a while. That wasn't, didn't get it done in 5 minutes or anything. And obviously I've written code like this before. I've written literally this program before, though I could show you this is probably pretty different in some ways than the one I wrote before, just because I didn't really have it that much in mind. I think I did this in some different, maybe more geometric way. I could probably math this out and come up with some simpler mathematical expression that would compute like the proper XY values. So I think what I did before, but that's good enough for now. So as with all these videos, I hope it is useful to you. This one was probably a long one, and if you start through to the end, congratulations. If you had to pause and go back and scratch your head a little bit about how this stuff worked, that is fine. Happy to answer questions about it. And as always, I hope it was useful for you. All right, take it easy.